Hi guys, welcome to the course of LLM Ops Masters. My name is Buktir Ahmed Bapi and I'm having more than 5 years of working experience in the field of Python, machine learning, deep learning, generative AI, MLOps and so on. So throughout the course, I'll be your instructor. And these are our social media. If you're interested guys, you can connect with us. So guys, the agenda of this video. So first of all, we'll try to see what is LLM Ops. Then we'll be talking about why LLM Ops important. Then third, I'll be talking about how LLM Ops differ from MLOps. So I think you already know that we have another domain called MLOps. We usually use this MLOps for the machine learning and deep learning model development. So there we just try to optimize the machine learning and deep learning model. Okay. So that's why I'm going to discuss how this LLM Ops is different, okay, from your MLOps. Otherwise, people will have the confusion, sir, whether this MLOps and LLM Ops is same or not, or it has some difference. So that's why I'm going to explain this part. Then once it is done, I'll be talking about how LLM Ops works. Then at the last, I'll be talking about some popular, tools and platform, for LLM Ops, which we usually use nowadays, whenever we develop any kinds of LLM powered application. So this is the video agenda. So first of all, let's try to discuss what is LLM Ops exactly. Okay, so the first topic, what is LLM Ops? See, LLM Ops is nothing but LLM Ops, that means large language model operation. We call it as a large language model operations. And what is the full form of MLOps? Machine learning model operations. So this is the difference, is a set of practices, then tools and frameworks, design efficiently, manage, deploy, and maintain large language models. Now I think you already know that we have various kinds of large language model, like we have GPT, we have Gemini, then we have Cloudy, we have Mistral, we have Llama, and so on. Got it? So what is the definition of LLM Ops? LLM Ops, that means large language model operation, is a set of practice, tools and framework designed to efficiently manage, deploy and maintain large language model. Nothing else. The same thing we used to also do inside our machine learning and deep learning. I think those who are from machine learning and deep learning, and if you know about MLOps, so what we do inside MLOps, we just try to we just try to do the same thing, right? We just try to do the optimization of the machine learning or deep learning model. Yes or no? Okay, that means whenever we try just try to train any kinds of machine learning and deep learning model, okay, we'll be using some set of MLOps practices whenever we'll be deploying and maintaining that particular model in the production. That time we'll be also using some tools and platform. Okay, so this is what your LLM ops. I think now you got it. So that means in machine learning, okay, sorry, in MLOps, what we do, we just try to optimize the ML model. Okay, and in LLM ops, we just try to optimize the large language model, that's LLM. Okay, so this is the difference only. Now let's try to discuss the second thing, why LLM ops is important. Okay, why LLM ops is important. So here, let me just write second, why LLM ops important. See, I think you know that LLM, okay, LLM become widely, okay, widely integrated with various kinds of tasks, like we have business, okay, application, then we have customer support application, okay, customer support apps, then we have also content generation, okay, content generation, then we have autonomous system, automation system, and so on. Okay, so we have various kinds of application nowadays, and all the applications, okay, all the applications need to be continuously, okay, continuously monitored and optimize. Okay, optimize. What I mean by monitor and optimize, so if I'm talking about chat GPT, let's say, so what happens in the chat GPT whenever we are sending any kinds of prompt, let's say I'm writing a prompt, let's say tell me about, okay, tell me about, let's say Python. Okay, let's say this is my prompt, I'm passing to the chat GPT, and what chat GPT is doing, it is giving me one response, yes or no, guys. Okay, response. So as an user, what is our expectation from this chat GPT? So definitely the question I'm asking to the chat GPT, I should have get the correct answer in a very fastest way, yes or no. Okay, so if my chat GPT is giving me slower response, I'm not going to use that application, because nowadays time is more valuable than the money. Okay, so people doesn't have that much of time of let's say whenever they are using any kinds of software, if this software is giving slower response, people are not going to use that. So that's why your application should be always optimized. Okay, it should be always optimized, the first thing, and you have to continuously monitor that application. Okay, let's say sometimes I think those who have used the chat GPT before, let's say whenever chat GPT came in the market, so that time chat GPT used to give a input feedback form. So there it was asking like how was your experience, whether you want to put any, let's say, feedback or not. So these kinds of, let's say, input form they used to give to the user, and user used to pass some feedback, or let's say if they're not enjoying, if they're not liking the product, they used to give the lower ratings, like that's how. So why they're giving you these kinds of, let's say, form, because they want to monitor, okay, they want to monitor their application whether it is working fine in the production or not. Okay, if it is not working, then they used to take the feedback from the user, they used to get the data from the user, again they used to retrain the entire model, okay, and they used to let's say again deploy that particular model in the production server. So that's why monitoring is also important. So it's not like that you have built your product and you are running in the, let's say, a production server and people are using that. You also need to monitor whether your product is working fine or not in the production, whether people are enjoying or not. Otherwise you will definitely lose your user. So that's why LLM ops is super important. With the help of LLM ops, we just try to do the same thing. We just try to monitor, we just try to optimize the entire LLM ops system, okay. So here for this we will be using some framework, we will be using some platform. Nowadays there are different platform, there are different frameworks are available. I'll be also talking about that one. Okay, now I think you got to know why LLM ops is important. Got it? Okay, now let's try to understand the next things. This one, how LLM ops is differ from ML ops. Okay, so for this let me just compare these two things. So this side I can compare LLM ops, and this side I can compare ML ops. Okay, so see, LLM ops require, okay, require vast amount of diverse, okay, text data. Nowadays we also have something called multi-model, so you can also consider it would be kinds of image data, audio data, and so on. And on the other hand, ML ops typically, okay, typically works with structured, okay, structured tabular data, okay. And if you have a very less amount of data, it will also work. But on the other hand, your LLM ops, okay, needs more data, okay, it needs actually huge amount of data. Otherwise you can't train actually large language model in a good way. Then it needs high, okay, high performance GPU and cloud resources to train the model, okay, to train and fine tuning and all. On the other hand, this LLM ops, sorry, ML ops generally requires lower computation, okay, lower compute power. That means you can also train on the CPU machine, okay, it will also work. Then here you need um, scalable scalable deployment for continuous inference, okay, continuous inference, okay. And here you need and here you can utilize often batch processing or periodic inference, okay. So what does it of mean? Let's say you have some machine learning data, okay, tabular data. So instead of doing continuous, let's say, prediction, you can collect some batch. Let's say you can give a duration. Let's say one day you will be collecting all the data, and next day you will be getting all the prediction. Because in machine learning we don't need real time actually, let's say, prediction. That's why we can also do something called this batch processing of the periodic inference, okay. But LLM ops actually you have to do continuous inference, because here people will be asking the question continuously and you have to get the response real time, okay. Then here you have bias, yes, okay, hallucination, hallucinations, and misleading outputs. Okay, and here you have bias monitoring is important but less complex, okay, compared to LLM. Okay, so in LLM, actually, I think you know that we have something called biases, hallucination, and misleading outputs problem. So this thing, whenever you want to monitor, you have to apply some complex strategy. But on the other hand, in the ML ops, okay, this is not that much of complex. Okay, you can easily handle these kinds of situations. Okay, so these are some actually key difference I can say between the LLM ops and ML ops. Now I think you got it. All right, now let's try to understand this thing, how LLM ops works. Okay, so I think you know that in LLM ops pipeline, what are the things we usually do? So let me just write here mm, how LLM ops works. How LLM ops. See, LLM ops follows a structured, okay, structured workflow, okay, workflow to ensure ensure the efficient management, okay, of LLM. So in LLM training, what we usually do, first of all, we do the data collection. Okay, data collection. After that, we do some pre-processing. Okay, it requires some pre-processing. Then we usually do the model training. Model training. Okay, model training. So sometimes actually instead of training the model, you also do something called fine tuning. So here I can mention fine tuning. Okay, fine tuning. So I think you know what is fine tuning. Even I will also discuss about this thing. Okay, going forward. Then once we fine tune the model, okay, and then what we do, we deploy this model. We usually perform the deployment. Deployment, okay. And after deployment, we do the inference operation. Okay, inference operation. So here actually your LLM ops comes. So let's say whenever you do the deployment of this particular model, or let's say whenever you are training this model, or let's say fine tuning the model, that time actually you'll be facing some challenges. I think you know that LLM, okay, LLM is a huge model. Okay, large language model, usually it's a huge model. It has actually a very large amount of parameter. Okay, millions of billions of parameter. So now let's say you are having one let's say system with Core i7 processor with 8 GB RAM. Now tell me how you will be training or how you will be fine tuning that model. Okay, definitely you will be getting the issue, and it requires actually lots of time to train. It requires actually lots of data. Okay, so for these we'll be utilizing the LLM ops technology here. So there are some tools like LoRa is there. Okay, LoRa is there. Then Hugging Face platform is there. Okay, Hugging Face platform is there. Okay, then we have some LLM ops platform is there. Let's say Bedrock is there. We have Vertex AI is there. Okay, Vertex AI is there. This is from AWS and this is from GCP. Okay, GCP. So with the help of these are the tools and framework, we usually do the training, we usually do the fine tuning. Okay, so LoRa usually do the quantization technique. It will load your model in a quantized format. Okay, and easily it can train your model on the lower configuration instance as well. Okay, this is the main advantage here. And whenever I'm talking about deployment, you also need to deploy this model as an endpoint. Okay, you also need to deploy this project as an endpoint. How it can be done? So there are some platform like Bedrock and Vertex AI. It is already having the model hosted, okay, in their platform, so that easily you can access the model through the API request, or let's say through the some other actually MCP protocol, and you can access the model. Okay, and you can easily do the inference operation there. So that's how actually you are optimizing the entire pipeline. You are optimizing the entire, let's say, inference pipeline. Whenever user is coming to the application, they are not getting any kinds of slow. Okay, they're not getting any kinds of, let's say, problem with that. Okay, so that's why LLM ops comes into picture. Otherwise, whenever you are creating this kinds of application, definitely will face the issue. I hope it is clear. So always optimization is important, and you have to continuously monitor your application. That's why we'll be utilizing these are the tools and technology, and we'll be learning these are the platform also. So nowadays, a popular platform you will be getting in the market like Amazon Bedrock is there, GCP Vertex AI is there, then Azure OpenAI is there. So these are the platform nowadays people are using, okay, for their product development and all. Even OpenAI you can also use, because OpenAI has also their API. With the help of API request, you can access the model instead of using the open source large language model. Okay, because open source large language model, at the end you have to download. You have to download in your system, then you will be using. But whenever I'm talking about OpenAI model, you have one OpenAI API key. So with the help of API key, you can access the model in their platform. Okay, similar if you're using Bedrock, Vertex AI, they also have one API or other MCP protocol. With the help of that, you can hit the model and you can access it. Okay, I hope it is clear. Now let's try to understand, let's try to see some popular here, popular tools and platform for the LLM ops. See, I already talked about that tools and platform. Like if I'm talking about the tools, we have various kinds of tools, like we have Hugging Face. Okay, Hugging Face is there. Hugging Face is a platform and tool, both you can consider. So it is having actually lots of functionality. With the help of that, you can also utilize the LLM ops technology. Like we'll be using something called LoRa, Q-LoRa technique. Okay, LoRa and Q-LoRa technique for the model training and fine tuning process. Then we also have something called ML Flow. Okay, ML Flow. Nowadays, ML Flow has also collaborated with the generative AI. So whenever you are, let's say, fine tuning your model, you can also track the experiment here. You can also monitor your LLM. Okay, so I can just write track experiment, okay, of LLM. Then we have some platform like Amazon Bedrock, AWS, Bedrock. Okay, it's a generative AI platform, complete generative AI platform. That means here you can do everything, and it has all the foundation model hosted, okay, in their platform. Like we have Llama, we have Mistral, we have Cloudy. Okay, all kinds of like powerful models are available there. Then from GCP side, GCP, that means Google Cloud, GCP, we have something called Vertex AI. Okay, Vertex AI was the first MLOps platform, but now they have also upgraded with the LLM Ops. So here also you can perform all kinds of LLM Ops operation. That means it also has some foundation model like Gemini. Okay, whatever Google model you can see, everything's are hosted there. It can be multi-model, it can be embedding model, it can be image model, it can be language model. All the models are available over the GCP. Apart from that, we have another one called Azure OpenAI. Okay, Azure OpenAI. But the problem with the Azure OpenAI is the account creation. So here you need the organization mail. I was trying to create the account, but it was giving me some issue. So that's why in this program, I'll try to more focus on the AWS Bedrock and GCP Vertex, because this has got more popularity nowadays. Okay. And we'll be also learning Hugging Face, and we'll be also learning how we can utilize the ML flow and all. These are the things we'll also try to learn. Okay. So guys, I think now you got it, like what is exactly the MLOps is. Okay, and why it is super important, and what are the tools, and what are the tools actually we have inside LLM Ops, and how it is different from the ML Ops. Okay, so this was the complete let's say overview about the LLM Ops. Now going forward, we'll be learning some more topic inside LLM Ops. We'll try to deep dive into the concept, and we'll try to also learn the practical implementation of it. Definitely your understanding would be more clear. Okay, And whatever resources I'm going to show you, definitely all the resources will be available. You can also get the resources. So with that, guys, I think you understood about the LLM ops. So yes, this was all about from this particular video. Thank you. Hi everyone, welcome back. So guys, in this video I'll be talking about why this LLM ops is different from your traditional ML ops. So for this, what I will do, I'll just try to write down each and everything. Yeah. So first of all, let's discuss about the LLM ops. LLM ops. Okay. So see, in LLM ops, the first thing we requires uh, use amount. Okay, use amount of training data. Okay, training data. So here it can be any kinds of data. It can be text, it can be image, okay, it can be audio, like that. Then we need high, okay, high performance GPU and cloud resources, okay, for the training purpose or fine tuning. All right. Because what happens whenever we are trying to train these kinds of large language model, this large language model has actually huge amount of let's say training parameter. I think you know that it has billions of parameter. That's why to load this model, definitely you need a higher computational system. You should have good memory, you should have good GPU, you should have good let's say resources in the system. Then you will be able to train and fine tune these kinds of model. Then uh, it requires scalable deployment. Scalable deployment. Why I'm talking about scalable deployment? Because let's say if I'm talking about chat gpt has actually lots of user. Okay, it has actually millions of billions user. So if they're coming to the chat gpt, if they're using at the same time, so this kinds of application should not be go down. Okay, it should not crash. That's why it should scalable deployment, and definitely it should have actually faster responding let's say time. Let's say if I'm sending any kinds of prompt, it should give me quick response. Okay, otherwise people won't be using that particular product, because nowadays we know that like time is more valuable than the money. Okay, so if I'm creating any software, it should be optimized, it should be scalable, so that people will come here and they can use very easily. Got it? And it should have also continuous inference. Why continuous inference? Because I think you know that these are like conversational kinds of let's say chatbot. So here people will be talking about the questions. Nowadays actually AI agents is also let's say integrated with that. So if you're asking anything, it will also search over the real time, okay, on the internet, and it will give you the response. So that's why continuous inference should be there. Okay, then in the LLM ops, we also have something called biases. Okay, bias hallucination, then misleading outputs. Okay, so in LLM actually we have these are the problem. Okay, and to handle these are the problem, actually we use some strategy and we just try to utilize the LLM ops, and we usually fix that particular problem. Okay, now let's talk about the ML ops. Okay, ML ops. So ML ops, you can see the first thing, this ML ops needs uh, MLOps also need actually lots of data, lots of data. But see, if you have actually less data, that time also MLOps will work, because inside MLOps what we use something called machine learning or deep learning. Okay, these are the model. And in LLMOps we use something called large language model. So that's why for large language model we need huge amount of training data. But in MLOps, if you don't have huge amount of training data, it is also fine. Still, you will be able to train the model. Okay, and most of the time you will see that this work with actually structured tabular data, tabular kinds of data. Okay, then second thing, the difference you can see, it requires low work compute power, lower compute power, okay, than your LLM ops. Because here we use something called machine learning model, and it's a statistical model. We also use some deep learning model, pre-trained model. Okay, so as compared to LLM model, you will see that these are the deep learning model are very lightweight and very it has actually less parameter. That's why definitely you can use lower computational power to train and fine tune these kinds of models. Here I can mention, so you can perform training, training and fine tuning. Okay, fine tuning you can do. Then third thing, you can do batch processing. Okay, batch processing or periodic. Okay, periodic inference. So what is batch processing and periodic inference? See what happens in machine learning. Let's say you have built one house price prediction. Okay, house price prediction. Okay, and you have deployed this model in the production. So instead of doing the continuous prediction, how you can predict? Let's say people have given you some test data, okay, from the different house. So what you can do, you can create a batch of that data, and you can do some periodic prediction. Let's say after one day, okay, after one day you can do the prediction. Let's say whole day you have collected the data, and after evening you have predicted, you have inference, okay, and you got the results. That's how you can do the periodic inference here, okay, with the help of this batch processing, instead of doing the continuous inferencing, because continuous inferencing it's not required here. Got it. But whenever talking about actually LLM powered application, here continuous inferencing is required. Okay, I hope it is clear. Then the fourth thing, you'll see this bias. We know that bias is also there inside the machine learning. Okay, so bias handling is uh, bias handling actually less complex compared to LLMs. Okay, LLMs here. So these are some actually difference I will see between these LLM ops and ML ops. Okay, that means here we are doing the same thing at the end, but in an updated way. Okay, so here we are handling large language model. That means big model. Okay, and for this we need huge amount of data, higher performance, actually computational power, scalable deployment. Okay, and we also use some strategy to handle the bias isolation and all. But in MLOps we use something called actually what I can say, let's say not massive model, but it is kinds of actually statistical model, and it's kinds of, let's say, big model, but not the massive model. So here we use other technique, like we if we have a actually less amount of data also, we can still train the model. It needs actually lower computational power. Even we can also perform the batch processing of periodic inference. Okay, and handling this bias, it's very less complex, okay, compared to the LLMs. Okay, now I think this part is clear. So yes, this is all guys about this particular topic. Thanks for watching. Hi guys, welcome back with another video. So in this video, I'll be talking about the evaluation from MLOps to LLM Ops. So I think you already know that previously when we didn't have the large language model, people used to use something called a machine learning model or deep learning model for various kinds of tasks. So if I'm talking about the machine learning, okay, machine learning, let's say ML. So inside ML, we have different kinds of learning. That means first of all, we have something called supervised learning. Supervised learning. Then we have unsupervised learning. Unsupervised learning. So in supervised learning, we give the label data. I think you know that. Let's say this is my model in supervised learning. Let's say this is my model. Here we give the X data as well as the Y data, and we get the prediction. Okay. And in unsupervised learning, here we only pass the input data, which is nothing but X. Okay. And here we get the Y. That means we don't pass the label here. And how it works based on the clustering technique. Okay, so we have various kinds of model in supervised learning. That means we have linear regression, logistic regression, random forest decision trees. Okay, and in unsupervised learning, we also we have some, let's say, clustering model like k-means clustering, DV scan. Okay, so these are the model actually we usually use here. And your machine learning, most of the time it will be working based on the tabular data. Let's say whenever you have the table data, okay, table data, that time actually it will work better, table wise data. Okay, because here you have some fixed column and rows. So here you have, let's say, 1 2 3 4 5. That means column is equal to 5, and 1 2 3 4 and 5, and row also is equal to 5. That means you have the fixed size. So here, let's say this many of columns is your X data, and this one is your Y data. That means 4 column you have for the input. Okay, and this is your label data. Got it? And you have some specific row size. But what about actually other data? Let's say image data. Let's say whenever you have something called image kinds of data, image data, audio data, then what? Or let's say text data, then what to do? Can we use machine learning model here? Can we use machine learning model here? You can use machine learning model, but it won't be working better here. Why? Because some of the data are actually unstructured here. What would be the problem? So whenever talking about image, I think you know that image has some dimension. Okay, it has some dimension, and inside of image actually we have some pixel value. Okay, so this is called actually pixel value, and this is the dimension. This is the height of the image. This is the width of the image. Yes or no? So let me show you. If I go to the website, let's say here, if you search like image pixel mnist, so see some of the example I can show you. Let's say this image. So if I zoom this image, see, you can see there are some pixel value. Okay, and the pixel value range is 0 to 255. So whenever it is having some number, so you can see there is a color, but whenever it doesn't have any number, that means 0, it is a white background. So that's why image has some pixel value, and this pixel value we have to give it to the model. But what with the problem, if you are using machine learning model can't understand, okay, can't extract the features. Let's say there 3 has been written, so this thing actually can't extract the machine learning model. So for this we use something called deep learning model. Okay, we use deep learning model. Deep learning. And in deep learning we have 3 kinds of neural network. We have something called ANN, that means artificial neural network. Artificial neural network. Then we have CNN, that means convolutional neural network. Convolutional neural network. Then we have RNN, that means recurrent neural network. Okay, so ANN, this is the foundation of neural network. So here we just try to understand how to build a neural network. So most of the time we will be using the tabular kinds of data here. You can also use the image data, but the measured actually image data you will be using in the CNN, that is convolutional neural network. Okay, so here you have something called convolution operation. With the help of that you can extract the feature from the image. So I think you know these are the basics I'm expecting, guys, because this is the prerequisite. You should have familiar with these kinds of CNN, RNN. Okay, then you'll be able to understand the latest LLM architecture. Got it? So it can extract actually features from the image, and after that we just try to pass the features to the neural network. Okay, to the neural network, and our neural network will be working fine. So let me show you one CNN architecture. So let's say there are different CNN architecture. I will show you, let's say VG16. So VG16 one CNN architecture. So it has actually two kinds of layer. See here, this is the architecture. So it has the convolutional layer, you can see. Okay, it has the convolutional layer. So whenever you are passing an image with the help of convolutional layer, it is extracting the features. Okay, and with the convolutional layer, it also uses something called max pooling and railway activation function. Then once a feature extraction is done, see, it's not like that it will only have the one let's say layer. It will have the multiple conv layer. Okay, from the multiple conv layer, it will be going, your image will be going, and it will be extracting all the features, okay, part by part, and these particular features would be stored in the feature store, and this feature store would be passed to the actually dense layer. That means your artificial neural network, and artificial neural network will try to understand the features, and it will give you the prediction at the end. Okay, so this is the entire CNN architecture. I hope you cleared. So all the CNN image data, all the video data will be passing to the CNN architecture. Now what about the RNN? Okay, RNN is the required neural network. So here most of the time we'll be working on the text data. Okay, text data, because text is unstructured data. Let's say whenever I'm writing a sentence, let's say I am, okay, I am puppy. So this is the my first sentence, and let's say I'm writing another sentence. Python is a programming language. So at the first sentence, you can see we have how many words? 1, 2, 3. And the second sentence we have 1, 2, 3, 4, 5. Okay, now you can see input dimension is not same. So whenever we are creating any kinds of neural network, let's say, okay, neural network, I think you know we create the neural network like that. Okay, neural network like that. So as per our first input, okay, what how many actually layer we should have in the first layer? We should have three layer. Okay, so I can remove one layer here, one neuron here. Okay, so that means 3 input you can pass here like that. Now when it will come to the second sentence, it needs actually 1, 2, 3, 4, 5. 5, okay, 5 neurons, but you don't have the 5 neurons. Now have you seen any kinds of network that will automatically create the neurons, okay, during the runtime? No, you have to previously build that particular network, then you can pass the data. So that's why this kinds of text is unstructured data. Okay, it doesn't have any structure, so we can't use this kinds of network here. Okay, for this we'll be using something called RNN, recurrent neural network, RNN. Okay, now let me show you one RNN network, how it will look like. So RNN architecture. Okay, so here is the RNN architecture, guys. So it will be working based on the timestamp. So I think those who have studied about the RNN, okay, you know that inside RNN we have various kinds of architecture, like GRU is there, LSTM is there, okay, then encoder decoder, then we also have something called attention mechanism. So because the attention mechanism is the very important things, based on that transformer architecture is created, and transformer is the core architecture behind all the large language model, okay, whatever we are using nowadays. So see, all the text has one timestamp. So let's say whenever I'm talking about I am Bappy, okay, so I has been written at the T1, I am has been written at the T2, and Bappy has been written at the T3. So it has actually one timestamp. Okay, so that's why we can also call it as time series data. That's why we have to use this particular architecture, so that it can unroll, okay, it can unroll that timestamp, okay, at the same time. Okay, so this is the actually mechanism of RNN architecture. Now I think you got it. So here, whenever actually we used to use these at the, let's say, model, okay, so there was a domain was proposed called MLOps. Okay, MLOps was proposed because we already know that if I want to create any end-to-end application, productionized application, at then we have to optimize that application. Okay, and for optimization, what we need some certain structured actually guideline, so certain some actually tools and frameworks, so that we can automate most of the tasks. Got it? In MLOps also we do the same thing. Let's say whenever we train any kinds of model, what we do? We usually do the data collection. Okay, data collection we do. data collection we do. Okay, then we do something called EDA. Okay, then we do feature engineering. Okay, then we do model training, then we do model evaluation. Okay, then after that we do the deployment. Okay, then after that we do the inference. Then after that what we do, we monitor the app. Okay, and to build this entire pipeline, okay, to build this entire pipeline we need some certain MLOps tool. And I think we know that inside MLOps tool we have different tools, like we have ML flow. Okay, ML flow is there, we have DVC is there. Okay, then we have Docker is there, we have Kubeflow is there, okay, and so on. So with the help of these are the MLOps tool, we build the entire pipeline. Okay, so from the data ingestion itself, from the till the deployment, till the monitoring, we try to add some MLOps tools so that we can automate most of the tasks. Got it. Now when LLM was introduced, okay, that means large language model, LLM. Okay, so people started using the large language model that time, because we know that. So let's say whenever we didn't have these kinds of large language model, how people used to do the NLP kinds of task. I think you know that in NLP we have various kinds of tasks. We have text classification, we have language translation. Okay, then we have sentiment analysis. That means whatever task we do nowadays, okay, over the chat GPT or over the large language model, all kinds of tasks we used to also perform. Okay, but for this we used to use something called individual model. So if you go to the Hugging Face platform, so there is a platform called Hugging Face. Okay, Hugging Face platform. So it has actually all kinds of models. Okay, let's see, if I go to the model section, let's say you only want to do text classification, you can filter out. So these are the models are available for the text classification. And see, you can see we have Fine BART, we have Distill BART. Okay, so these are the model we used to use. So those who have already worked with the traditional NLP, I think you know that. Yes or no? Got it. So this is called actually LM model, that means language model only. But later on, actually researchers introduced something called large language model and multi-model. That means the GPT, then Mistral, whatever model actually we usually use nowadays. Let's say if I'm talking about Llama, this model is also available over the Hugging Face platform. And what is the main advantage to use the model? It can perform multitask. That means whatever task we usually do inside NLP, all the tasks you can perform with a single model. Okay, and it will work like a human. Okay, that is the main advantage here, because it is having huge amount of parameter size. All right, so that's why this model got big. Okay, model got big, model complexity actually increases. So that's why MLOps fails here most of the time. Okay, MLOps fails here. That means whatever traditional MLOps pipeline we used to use, okay, in the machine learning or deep learning, so that will not work with respect to the large language model. For this, we have to use something called LLM Ops. Okay, LLM Ops, large language model operation. That's why this concept has been came. So here we use some certain frameworks and tools, like we have LangChain. Okay, for the orchestration, we have LlamaIndex. Okay, for the orchestration. So see, you can't implement the LLM application with the help of TensorFlow and PyTorch. For this, you have to use the LangChain and LlamaIndex. You also need to use some vector database. Okay, you can't use the traditional database. Then you have to use nowadays Hugging Face also has some LLM Ops functionality, like you can also perform the quantization with the help of LoDA, QLoDA. Okay, these are the thing. Then there are some platform are also available, like AWS Bedrock. Okay, Bedrock. So let me write down AWS Bedrock. It's a LLM Ops platform. That means a complete generative AI task you can perform. Then we have GCP Vertex AI. Vertex AI. Okay, then we have Azure OpenAI. Okay, these are the LLM Ops platform. LLM Ops platform. Okay, platform. So that's why LLM Ops came in the market. Okay, so when we didn't have the LLM, large language model, people used to use machine learning. But whenever you are working with the GenAI, that is large language model, you have to use LLM Ops here. Okay, and in this program, we'll be learning some tools of the LLM Ops, and we'll be also focusing on the LLM Ops platform. and we'll be building some amazing application. Okay, so yes guys, this is the entire evaluation of the MLOps to LLM Ops. Okay, now I think you understood. So here in the LLM Ops, we more focus on the optimization of the application and how we can build it scalable. Okay, we just try to take care, these are the part, because at the end large language models are big, and if you have actually low configuration system, you can't download that in your system, and you can't do the fine tuning, and you can't actually optimize your application. For this, definitely you have to utilize these are the LLM Ops tools. Okay, that's why it is required. So yes guys, this is all about. I hope you liked it. So thank you so much guys for watching. Hi guys, welcome back. In this video I'll be talking about some key challenges. So here let me write some key challenges. Challenges, okay, in LLM Ops. So the first key challenge we usually face are model deployment, okay, and scalability. Scalability. Okay. Second challenge we usually get called data privacy, security, okay, and compliance. Okay. So what is data privacy, security, compliance? See, uh, whenever we are using any kinds of custom data, that means your private data. So sometimes what happens if you give that data to the LLM, so there is a possibility your data may get leaked. Okay, so that's why data privacy is super important. And what about security and compliance? Okay, see, nowadays actually if you see over the chat GPT or any other application, if you're asking any kinds of harmful content or let's say sexual content, these are the model will not give you the response. So that's why you also need to aware about the policy, okay, policy of your application. Otherwise people will be using these are the let's say application, these are the model in a bad way. Okay, they will be generating the sexual content, they will be generating the harmful content. Okay, from that, so you also need to take care of this part, and that's why there is a challenge whenever you are building the large language model, you also need to take care of this part. Okay, I hope it is clear. Then the third challenge people usually get called monitoring. Monitoring, evaluation, okay, and continuous improvement, the improvement of the model. So this is another challenging task inside this LLM Ops. Then we have another one called prompt engineering, okay, and version management. Version management, okay, model version management. So this is another actually challenge, okay, key challenge inside LLM Ops. So yes guys, these are the challenges we usually face inside LLM Ops, and we have to overcome whenever we are implementing any kinds of application. We have to overcome these are the challenges. Okay, then we'll be implement a scalable product. Got it? And all the let's say challenges can be solved with the help of LLM Ops, or with the help of some LLM Ops tools, LLM Ops platform. Okay, that's what actually we'll be learning through the entire course. Okay, so I hope you guys got it. So yes guys, this is all about our key challenges inside LLM Ops. Thanks for watching. Hi everyone. In this video, I'll be talking about LLM lifecycle. So see, inside LLM lifecycle, we usually follow some steps. Okay, and first of all, I'll let you know what is LLM lifecycle exactly. Okay, we also call it as pipeline. Okay, you can also call it as LLM pipeline, or let's say generative AI pipeline. Okay, you can call everything. So what does it mean of lifecycle and pipeline? First of all, I'll try to give you the definition. So here, just let me write LLM uh, lifecycle. Lifecycle. See, LLM lifecycle is nothing but LLM life cycle is a set of steps, okay, set of steps followed to build, okay, and end to end, okay, end to end software, okay, end to end software. That means here what we do, we just try to break the problems into several sub problems, okay, and then try to develop each sub problem step by step, okay. So this is called actually LLM lifecycle. Now inside LLM lifecycle we have different let's say component. So the first thing you can consider, we have data acquisition, okay, data acquisition. So here we just try to collect the data. Now data can be available, okay, data you can extract from different API. You can also do the web scraping, you can also collect your own data by doing some survey. It's up to you. That means you have to collect your required data for the training. So once data collection is done, you usually do the data preparation, okay, preparation. Inside preparation you apply some cleaning technique, you apply some let's say feature engineering technique, okay. So with the help of that you just prepare the entire data, okay. Now there is another section, we also name it as FE, feature engineering, okay, feature engineering, individual component feature engineering. So in feature engineering, what we do, we just try to create features. We try to create features. If any transformation is required, we usually do here. Then we also do the vectorization. That means we create the embeddings here mostly. Okay, embeddings of our text or any kinds of data. Because we know that large language model can't take the raw input, raw text, or let's say video, it can't take. So for this, what you have to do, you have to convert those data to the numerical representation, and everything can be done inside FE, that means feature engineering, okay. That's why it is super important. Then once it is done, we'll be doing the modeling, okay, modeling. So here we just train the model, we train model, okay, and train the model, okay. So once model got trained, what we usually do, we do the model evaluation, model evaluation, okay. So here inside model evaluation we have two kinds of evaluation. The first one is intrinsic evaluation, other is extrinsic evaluation, okay, extrinsic evaluation. So in intrinsic evaluation, what you usually do, you try to apply some evaluation metrics like and you know that like we have different kinds of evaluation metrics are available, okay, based on the task you are doing, okay. Those are the metrics you will be applying. And what is extrinsic evaluation? Extrinsic evaluation means after deploying the model, okay, after deploying the model you will be doing this extrinsic evaluation. So here let's say my model is in the production, and people are using my application, okay, and you are continuously like let's say monitoring your let's say model. And if user is not liking your model, let's say if they're giving the bad feedback, based on the bad feedback you are again let's say updating your model. This is called extensive evaluation, okay. So after going to the production, you usually apply this particular extensive evaluation, okay. I hope you cleared. Now after model evaluation, we usually do the deployment, then we do the monitoring, and model update operation, model updating, okay. So this is the entire actually LLM lifecycle, okay, we usually follow whenever we just try to train any kinds of LLM from scratch. Even you also do the same thing whenever you do any kinds of fine tuning, okay, of any kinds of LLM, because training is a costly task, and for this we need lots of computation, for this we need lots of cost. So that's why we usually do the fine tuning of the LLM, okay. So there is another technique, okay, we usually follow. So instead of fine tuning, also you can again use your custom data. The concept name is RAG, that means retrieval augmented generation. We'll be also talking about this part. Got it? So yes guys, this is all about, I think you got to know what is the LLM lifecycle. And yeah, this is all. Thanks for watching. Hi everyone. In this video, I'll be talking about some core components of an LLM Ops pipeline. Okay, so let me just write down here um, core component of LLM Ops pipeline. See, the first core component is data pipeline. Okay, data pipeline. So definitely make sure whenever you are training any kinds of LLM from scratch, you have to take care of the data pipeline. Okay, so data source can be anywhere, whether you are let's say collecting the data from the API, you are scrapping, okay, you are using some internal data sets, so you should have the proper pipeline. Okay, so then after that you also need to do some pre-processing steps. Okay, like you have to do some tokenization, then formatting, okay, cleaning, then we'll be using the data. I hope it is clear. Then the second pipeline I can talk about model management. Model management. I already talked about why model management is important. Let's say I'm talking about, let's say, chat GPT. So if I'm creating the chat GPT and if it is slow, okay, if it is running slow, so if user is coming to my application app, if they're getting some delay, definitely they are not going to use my application. That's why model management is super important. Okay, whenever you are managing the model, make sure you are storing the model in a good storage. Okay, and it should have the tracking functionality, it should have the good infrastructure. Okay, and most of the model you have to run on the GPU based machine, because otherwise actually you won't be getting the faster inference. Okay, so that's why you have to keep the model in the a good infrastructure. Okay, GPU based machine, most of the time you have to take it. Then the next thing, you have something called prompt and template management. Template management. So this is another super important concept, prompt and templates management, because LLM is all about prompting. So whenever you are using, let's say, LangChain or let's say LlamaIndex or any other orchestration framework, definitely you have to create the prompt template. Okay, let's say user can give any kinds of prompt, and internally you have to build the template so that it can match with the task they want to perform. So that's why it is super important. Then I can talk about model training. Another let's say super important pipeline I can talk about, because in the model training there will be using some technique like quantization technique, will be applying LoRa, QLoRa. Okay, so it's also part of LLM pipeline, LLM Ops pipeline. Then model evaluation. Model evaluation. So this is another component. So here you have to evaluate the model. Okay, whether your model is good or bad, you have to evaluate. Then the last thing, continuous. Okay, continuous uh, learning loop. That means if user is giving bad feedback, okay, it should learn the new things. So nowadays we can also, let's say, solve this particular problem with the help of AI agents. Now our application can search over the internet real time and it can get the response. Okay, this is called agents. Okay, we can also build the agents. Nowadays all the apps are using the same thing. If you go to the chat GPT and if you're asking, let's say, what is the latest news of 2025, this will give you the response. Okay, so that's why this is also super important. So yes guys, these are actually, let's say, core component of the LLM Ops pipeline. Okay, thanks for watching. Hi everyone, welcome back. So in this video I'll be talking about some tools that are actually shaping our LLM Ops let's say domain. So there are various kinds of tool you will be getting in the MLOps. Okay, in the field of MLOps, let me discuss some of them. So see, orchestration tools wise, you will be getting something called LangChain. So this is another actually, so this is one of the amazing actually orchestration tool. With the help of that you can build the entire GenAI system. And LangChain also has some ecosystem, like it has LangSmith. Okay, this is another LLM Ops tool you can consider. Then it has LangServe. This is also another LLM Ops tool. Then you have something called LangGraph. So LangGraph is the agentic AI let's say framework. With the help of that you can create the AI agents. Then second, you have something called LlamaIndex. So this is another orchestration framework. With the help of that, you can orchestrate the entire application. Orchestration means you are creating the complete system. That means you are loading the data, you are loading the model. Okay, everything you are loading in an efficient way. That's why it is super important. Then there is another one called Haystack. Okay, Haystack. This is another orchestration tool. Then we have uh, vector databases. Vector database. So we have various kinds of vector database, like we have Pinecone. Okay, we have ChromaDB. Then we have Waviate, we have Fires, and so on. So these are the vector database, and here we can't use any kinds of traditional database, because traditional database can't do the similarity search operation, can't do the retrieval operation. That's why we'll be using the vector database, and this is also part of LLM Ops tool. Okay, I think you got it. Then we have something called Hugging Face. So this is another actually platform and tool you can consider for the LLM Ops. So there we have different components we can use for the LLM Ops work. Let's say we can use the quantization technique if you want to do the fine tuning of your LLM. Okay, so then you can also host the model in the Hugging Face let's say platform. It is also possible. Okay, then we have something called ML Flow. Okay, so this is another LLM Ops tool. With the help of that, you can track the experiment, okay, of your LLM. Then we can also add some technique from the MLOps, like CI/CD. So if we want to deploy the model, we can use the CI/CD technique. We can use GitHub Actions. Okay, we can use Jenkins. We can use Circle CI. With the help of that, we can also deploy the model. And some of the amazing platform actually you have inside LLM Ops. So let me write down them. So the first platform you have AWS Bedrock. Okay. Second, you have GCP Vertex AI. And third, you have Azure OpenAI. Okay. So these are the platform from cloud provider. So everything you will be doing in the cloud. And what is the main advantage? So here you don't need to download the model. Okay, let's say if you're working with an open source model. Okay, open source model, let's say any kinds of open source model. I think you know that there are thousands of open source models are available. Okay, let's say we're working with Llama. Okay, Llama, let's say 3. Recently they have published the 4. So open source model wise, if you're working, you have to download this model in your system, then you will be able to use it. And for this, what you need a good infrastructure. Otherwise you won't be able to use that particular model. Okay, but in platform, what happens, they have already hosted these are the model in their platform, in their cloud, and they have given you one API access. So with the help of API, you can access the model and you can do your work. Let's see, you are using Core i3 processor, still you will be able to work with the model, okay, very easily, okay, with a very fast inference time. So that's why these are the platform is getting more popularity nowadays, because deploying your own model, it's super challenging, and it has actually more cost involvement. Okay, so that's why we are not going to host our own model. Okay, for this you can use something called DLC, deep learning container. So you can use something called Amazon SageMaker to deploy your model, but at the end, if you see the cost of Amazon SageMaker per hour, it would be huge. So that's why we are not going to follow this approach. So we'll be using some platform. There we'll be using the foundation model. With the help of that, with the help of some orchestration framework, we'll try to develop the projects. Okay, and we'll be integrating the vector database, and then we can build the entire LLM Ops solution. Okay, I hope it is clear. So yes, guys, these are some actually tools that are shaping the LLM Ops, and definitely you will be using this as the tool going forward whenever you will be implementing any kinds of LLM powered application. So yes, thanks for watching. Hi guys, in this video I'll show you some real world use case of the LLM Ops. See, I think we are already using these other tools in our day-to-day life. The first tool I can show you, the ChatGPT. So ChatGPT is one of the tool they are using LLM Ops in their development. That means, let's say if I am giving any kinds of prompt, let's say I'm asking what is Python. Okay, now see, if I send this particular let's say prompt to the ChatGPT, instantly it will give you the response. See, instantly it will give you the response. That means internally they are using LLM Ops. Got it? And they have hosted their model in their platform. They have created one API, okay, and they're giving this kinds of like very fast response because they're using very good infrastructure in the backend. Got it? Apart from that, we have something called Gemini. Okay, so this is another actually, let's say, a tool from the Google side. Here also you can do the same thing. That means these are the real world applications are using these LLM ops because this is like very huge model internally they're using. I think you know that GPT 3.5, GPT 3. GPT 4, like how many, let's say, parameter they have, okay, in their model. You can see the model list. Let's say if I'm talking about OpenAI model list, okay, so they have already given the model list with respect to the token size and everything. You can maybe check here. Let's say I'm talking about this GPT-4 or mini, so you can see here the model size, okay, so you can see the context window, okay, and they have also given the parameter size, everything they have given, so you can check it out. So yes guys, these are some actually real world use cases you can talk about of the LLM ops. Apart from that, there are various kinds of tools, okay, I can talk about like AI customer chatbots are available, then local uh, then legal document summarizations are available, then medical report generations are available, then code generations are also available, okay, then recommendation system, then AI powered educational tool, content generation for marketing, all kinds of applications, okay, whatever applications you are using, okay, you can see over the internet all the applications are using. So yes, all these kinds of tools are using LLM ops technology in their development, okay, I hope you got it. So yes guys, this is all from this particular video. Thanks for watching. Hi guys, in this video I'll be talking about what are the skills are required to become an LLM ops engineer, okay, because many people has the questions, if I want to be a LLM ops engineer, what are the skills I should have. See, to become LLM Ops engineer, LLM Ops engineer, LLM Ops engineer. So the first skill you should have LLM fundamentals. Okay, fundamentals. Okay, and prompt engineering. Prompt engineering. Okay. Because unless and until you are not familiar with LLM fundamentals, like what is large language model, how it works, what is prompt engineering, how prompt works, okay, definitely you will have lots of confusion. Then you should have actually machine learning, and little bit NLP concept. Okay, NLP concepts. Like you should know like what is supervised, unsupervised learning, and in NLP like what is, let's say, LSTM, GRU, encoder, decoder, attention mechanism concept. Okay, you should have these are the let's say idea. Then transformer architecture overview. You should know these are the thing. Then you should have knowledge on. Then you should have knowledge on basics of MLOps. Okay, MLOps, because inside MLOps actually we have different tools, okay, and it's not like that uh, we won't be using any kinds of MLOps tools here. We will be using MLOps tools. If I'm talking about, it's a Docker is a MLOps tool, right? We will be using, okay, in LLM ops also. Then we have something called MLflow. We'll be also using that because ML ops is a technology, so there will be learning how to do the model optimization, whether it's a machine learning model, whether it's a deep learning model. These are the thing we'll be learning, and the same concept you can apply in the LLM ops. Okay, only maybe some tools will be changing, but at the end the concept are same. Okay, so ML ops knowledge is required, a little bit of ML ops, and here you'll be also learning some cloud platform like AWS. You'll be learning GCP, you will be learning Azure. Okay, so cloud knowledge required, so cloud platform knowledge are required, okay, at the end. then then you should familiar with generative AI. Okay, generative AI product. So to build this kinds of generative AI product, what are the tools and technology we use? Let's say LangChain, okay, LangChain, then LlamaIndex, vector database, RAG, okay, fine tuning. Then we also use something called agents. Okay, so these are the concept you should familiar. Okay, if you're familiar with, definitely learning MLOps would be easy for you. Okay, and you will be become a good LLM Ops engineer. Then once it is done, you can start exporting LLM Ops. Okay, LLM Ops. So inside LLM Ops, you can like learn some LLM Ops tool. Okay, LLM Ops tool. I already talked about the tools. I think you know that. Then some platform. So platform wise, I think you know that we have three kinds of platform, like Bedrock is there, Vertex AI is there, and Azure OpenAI is there. Okay, you can master all of them. So yes, guys, these are the skills are required if you want to be a LLM Ops engineer. Okay, and we'll try to learn. These are the tools and these are the platform in this particular program. Thanks for watching. Hello everyone. So let's talk about the course overview and how you can navigate this particular course series. So in this particular program, you will be getting actually lots of module. Like you can see, these are the module you'll be getting. Okay. So see, you have to watch these are the recording one by one. It's not like that. Let's say you have started with first module, then you are going to the let's say fifth module or let's say sixth module. Okay, not like that. If you want to understand the entire LLM Ops concept, okay, the way actually I have designed, you have to go through step by step. First of all, try to complete let's say introduction to LLM Ops part. Okay, so here you will be getting some sub let's say topics. Okay, in that actually I have let's say discussed so many things. Then just try to complete the foundation of LLMs, then LLM Ops to tooling landscape, then data management for LLMs, then training and fine tuning of the large language model. So here we will be talking about actually foundation of LLMs, like different models are available, different let's say code models are available which is using in the LLMs. Different components will be also talking about, okay, of the large language model. Then I'll give you the entire tools overview, what are the tools are available, and we'll be also learning the practical implementation of it. Then data management will be also learning. Then training and fine tuning, it's super important. So here we'll be talking about LoRa LoRa quantization technique. Then retrieval augmented generation, super important concept. Okay, because going forward you are not going to train or let's say fine tune the LLM. Instead of that, you will be implementing the RAG application most of the time. Okay, because RAG helps us to connect with our custom documents. Okay, instead of training the model, fine tuning the model. Then we'll be learning about the model serving and inference. Then we'll be also learning the evaluation and monitoring. Then security, privacy, ethics. Okay, then LLM Ops platform will be learning. So inside that we'll be learning like Vertex AI, Bedrock. Okay, these are the things we'll be learning. Then after completing all the topic, we'll be doing some projects. Okay, so this is the entire actually overview, and that's how you have to navigate the entire course. Okay, then you'll be able to understand each and everything I have explained here. So yes guys, so now let's start with our next actually let's say module, which is nothing but foundation of large language model.